Good afternoon, everybody. Uh, Today we are going to discuss one of the basic topic, Surds. Right. Clearly, we'll discuss about Surds now. Okay. Now, yes, in this topic, all of you, please listen. Uh, we have definition of Surd. First, what is the symbol meaning? Then afterward, definition of Surd. What is Surd? What is not a Surd, etc. These all things we are going to discuss. And the next one is uh, classification of Surds. After we'll discuss first what is mean by symbol, then afterwards Surd definition, then afterwards classification of Surds, then afterwards uh, what is square root, what is cube root, and then afterwards RF, a rationalizing factor. Okay, these are the things which are there in this topic. Okay, one should have clear idea about the topic, then it is good now. These are the things are there in the topics. So let us start. Okay, here you see this Nana. In this topic, see this one symbol. This is called nth root of. What is that? Here you see principal nth root of A. You can call it as what, Nana? It is principal nth root of A. Principal nth root of A. In other words, what is that? How we are going to define? You see here. Let n be a natural number. That means I want to tell you that you see this Nana, this symbol we are going to talk about. What is n? What is A? What is the structure is called? You may get so many doubts. These all doubts are you will have what answer in this definition. See here, n. What is n? N is a natural number. What is that, Nana? N is a natural number. This is what natural number. And what type of natural number? One? No, certainly not. It is a greater than one. Okay, not one, greater than one, any other than one. And A, what is this A? A is be a real number. Remember, a real number. A is what? Real number. This is natural number, and this is real number. Right? Real number. Then this total structure is called principal nth root of A. How we are going to define? Defined as a unique real number. What is that, sir? Unique real number. Let us say that B, if it is B means A is equal to B to the power of n. Okay. Now we talk about this one. Now clearly, do we have here what are the names of this? Right, sir? Those all things I want to write here. You just see this Nana. You see here the name of in this symbol n is called index, or you can say that what order. Right? What is A? A is called radicand. I said that real number. This real number name is called what? Radicand. Right? Radicand. Then n is a natural number. It is what? Greater than 1. Not to forget about that. And this symbol is there. Na? That symbol we can call it as this sign, radical sign, we can call it as that. Now I would like to give some examples here. Few examples I want to give. What are the examples here? Suppose if I write cube root of 125. This can be expressed as 5 Nana. It may be written as 125 can be written as 5 cube. Right? I am not saying that this is a surd. No, it's a symbol. It's not a surd. Certainly not a surd. And cube root of 1 by 1331 can be written as 1 by 11. So you can write 1 by 1331 is equal to 1 by 11 whole cube. Right? So like that, you can give several examples. 16 is there. You can write 4. That is nothing but 16 is equal to 4 square. You can write. Yeah, you can write fourth root of 81. If I write here, this is what 3. This can be written as what? 81 is equal to Okay, 3 to the power of 4, you can write. These are all examples which I have given to you. Now we will discuss what is the difference of this symbol third. What is the symbol of, or what is the difference of this principal nth root of a and the third? That difference I want to tell you. You will know. You'll come to know the definition of third is like this now. Yeah, here you see the definition. There is a difference between the symbol, okay, nth root, principal nth root of a and a third. What is that exactly? Here I'll mark the differences. You please catch this particular point. See here, there also I said that n is a natural number. N is a here what Nana? N is a natural number, not rational. It is a natural number. N is a natural number. Natural number greater than 1. There also what? Natural number greater than 1. A, B, any rational number here. There I said that real number. That is a big difference. In the case of third, A becomes what? Rational number. Okay, then this symbol is called what? Third. If what if you see here a is not the nth power of a rational number, say b, that is nothing but a should not be equal to b to the power of n. Whereas in a principal nth root of a, that a is equal to b to the power of n. Whereas in the case of third, a is not equal to b to the power of n. That is a big difference. Mathematically, same story I wrote here, Nana. Okay, rational number symbol. This is called third. If directly, you can write directly. Here you see here nth root of a rational number. Instead of saying this all, simply you write the statement, that is more than enough. What is b? B is a rational number. That's it. Now question is, to get clarity, I want to give here the clear examples. Third, and you see here, not a third. What is third? You see, if I write root 2, rational 2 perfectly, it is third. But whereas here in the case of this one, if I write cube root of 1331, is it a third? Certainly not. Why? 1331 can be written as 11 cube. 11 cube. So that it is not a third. Because the reason is that it can be expressed as some power of rational number we can express. Right? That's why it is not a third. Suppose you can write here like this, cube root of 3. There's a meaningful. Cube root of 31 also you write down, it is a meaningful. But whereas here, suppose if I write here pi, what is pi, Nana? Pi is irrational. As I said it to you that integrand must be what? Rational. Whereas pi is what? Irrational. That's why it is not a third. Irrational. Pi is irrational. That's why it is not a third. Okay, somebody want to say like this, 1 by root 2, root 3. What happened? Nothing. It is a third, absolutely third. There is no doubt. But whereas here, suppose if I write here 2 plus root 3, is a third? No, certainly not. Why? Reason is 2 root 2 plus root 3 is a irrational number. So with this very clear, Nana, all irrationals are not surds, but all surds are irrational. Right? That is the most important point which you have to know, Nana. All irrational. Yeah, here I wrote all surds are irrational numbers, but all irrational numbers, okay, numbers are not surds. Okay, we'll move on to the next page. You see here, next what I'm going to discuss. Okay, now you see here classification of surds. Now we can classify surds like this. One is simple surd, or you can call it as monomial surd, right? Second one is compound surd. Next one is in compound surd. Again, we are going to discuss two more points: binomial, trinomial surds. We'll discuss. The next one is entire surd. The next one is what? Mixed surd. Next one is what? Similar surd, dissimilar surds. Okay, and these are the things which we are going to discuss one by one. I'll write now. You see this, guys? I'm going to write. Yeah, you see, as I said to you that simple surd. What is the meaning of that? Very simple. A surd which consists of only one term is called simple surd. Now you see here, which one is a simple surd means. Here I'll write simple surd. Root 2 is a simple surd. Okay, 3 root 2 is a simple surd. 1 by root 3 is a simple surd. Okay, 1 by 3 root 2 simple surd. Cube root of 3 simple surd. These all are simple surds. Okay, these all are simple surds. Right, several examples we can use for simple surd. Now, I'll move on to the next definition. What is that? Compound surd. I want to go for it. Okay, compound surd. What is that compound surd? Means a surd which consists of two or more than two terms is called compound surd. Okay, guys, I'm going to write that one. Yeah, here you see this one. Whatever I said, I wrote the same. A surd which consists of two or more than two or more consist of two or more than two terms. Two or more than two terms. More than two terms. Right? Is called what? Compound surd. Examples I'll give now. You can write root 2 plus root 3, 2 root 2 minus root 3. Okay. 3 root 5 plus 1 by 2 root 2. Yeah, this all. Not only this, 2 plus root 3 plus root 5. Yeah, fine. 2 minus root 3 plus 5 root 2. Yeah, these all are what? Compound surds only. As I said it to you that after compound surd, I want to discuss about binomial surd. Okay, binomial surd. What is binomial surd? A compound surd which consists of only two terms is called binomial surd. That only I want to write. Yeah. Whatever I said, I wrote here. You see, compound surd consists of only two terms is called binomial surd. Here, better example. 2 minus root 3, 2 root 2 plus root 5, or 2 minus root 3. Yeah, you can. One is rational, another irrational also you can write. You can write like this also, 1 by root 3. Yeah, fine. These all are what? There must be what? It should be a surd and it should contain only two terms. Then only you can say that it is binomial surd. And in the same fashion, I can go for trinomial. Trinomial surd. Same story, Nana. Same definition I can write. A surd consists of only three terms is called. Examples here I'll write. You see this? You can catch 2 plus root 3 plus root 5, 2 root 3 root 2, 1 by root 5. Yeah, these are all things. 1 by root 3. Chalo. You take as many examples as you want. Root 2 plus root 5 plus root 7. Yeah, these all are what? Three terms must be there. One is rational and the two terms are what? Surds. No problem. There must be what? Three terms. Right. The same definition I want to write here. You see this, Nana? Whatever I said it to you, I want to write. Yeah, you see here. The compound surd consists of only three terms is called trinomial surd, I said. Now, we'll go for another one, Nana. What is that? Similar surds. We'll go for similar surd. What is mean by similar surd? Yeah, you can write here. You see, root 2 is there, root 3 is there. Right. If I write like this, these are similar? No, certainly not. But 1 by 2 root 3, 1 by 5 root 3, is it similar? Yes. That means what I want to say, different rational multiple of same surd. What? Different, difference, different rational multiple of same surd. We can call it as what? Similar surd. Otherwise, dissimilar. Right. Even though these two are same, Nana, 2 root 2 is there, 2 root 3 is there. These two numbers are rational numbers are what? Same. But the surds are different. Then these are what? Dissimilar surd. The same thing I'm going to write over here. You see. Yeah. Whatever I said, na, the same thing I wrote here. You see, for the similar surd, different non-zero rational multiple of same surd. Yeah, first example. You see here, 1 by 2 root 3 minus 5 by 4 root 3. This is what? These are what? Similar surd. Second example, I told here also the same thing, right? Minus 5 root 2, 10 root 2. These two are also what? Similar. Third one, okay, 5 by 4 root 3, 6 by 7 root 3. Yeah, these are also what? Similar surd. Now, I would like to give some examples for dissimilar surd. Right, I already explained, but even though I would like to give example here. One example, you see this, Nana? 2 root 2, 2 root 3. Even though rational number same, but the surds are different, therefore they are dissimilar. Which are not similar, simply you can say, okay, 1 by 5 root 2, okay, 3 by 5 root 3. Yeah, these are what? Dissimilar surd, guys. Next one, I want to discuss about mixed surd, Nana. What is that? Mixed surd I want to discuss. Okay, mixed surd. Mixed surd. Mixed surd means what? Suppose A is a non-zero rational number. What? A is a non-zero rational number. Then the surd of the form, like this now. The surd of the form, nth root of A. Okay. And B is a surd, root B is a surd. Right? A is a rational number, root B is a surd. Then you can say like this, A into this one, or A plus or minus B. Any surds which are in this form, you can call it as what? Mixed surd. The same thing I would like to write whatever I said it to you. Yeah, whatever I said, Anna, the same thing I said it to you. Non-zero rational number A, nth root of B is a surd, right? Nth root of B is a surd. Then we can call it as the surd of the form A nth root of B, A plus or minus nth root of B, okay, are called mixed surd, right? Okay, 1 minute here. Right. You see here, guys, mixed surd. What are the examples, Nana? The examples are like this. 3 root 2, right? 1 by 5 root 3. Yeah, these are all mixed surds. Another one, 2 plus root 3 is mixed surd. 2 minus root 3 is a mixed surd. But if I write root 2 plus root 3, not a mixed surd. Not a mixed surd. Right? Not a mixed surd. Right? If I write here only root 2, not a mixed surd. Right, Anna? Not a mixed surd. Yeah. 1 is also there. Na? We'll avoid this. There is a chance you can argue with me with 1. So it is a mixed surd. Yeah, you can say. Right. But A should be rational number. Non-zero rational, I said. Yeah, fine. It should be in this form. This is not a mixed surd. Now, I'll move on to the next one, guys. Now you see here, pure surd. Very simple, Nana. Nothing is there, nothing special is there in this. A surd of the form nth root of A is called what? Pure surd. So if I write here, root 2, yes, pure surd. Right. Cube root of 5, pure surd. Right. Fourth root of 2, pure surd. Right. But if I write 2 root 3, not a pure surd. Not a pure surd. Right. It should not be entire side. Everything should be there inside. These are pure surds. This is not a pure surd. Now, if somebody asks me, sir, what is quadratic? What is binomial? What is quadratic surd? What is biquadratic, etc., etc.? They said nothing to worry. Yeah. If you say that surd definition, you just observe the surd definition. Surd. Right. What is the surd, Nana? Nth root of A. We wrote like this. Is a surd. Suppose if it is a surd, the order, what I said, n is a order. So that we can say that order of the surd is here. What is the order of the surd? Order of the surd is n. Suppose if I write root 2, what is the order here? 2. If I write like this, what is the order here? 3. Right. So you can call it as, this is called as binomial because order is 2, no? Binomial. So quadratics, no, not binomial, quadratic. I'm extremely sorry. Not binomial. This is what quadratic said. Quadratic. What about this one? Cubic surd. Right? If I write 4, this is what is the order of this one? 4. This is called biquadratic. Right? Surd of order n. This is what surd of order n. What is the order of the surd means? N. What is the order of this surd is 2. This one is what? 3. This one is 4. Now. This, okay, we got it till here. Now the questions are, here we'll do some questions here now. Yeah, you see here, convert the following surd into surd of order, surd of the given, okay, given order, surd of the given order against it. Root 2 is given. I have to express this root 2. What is the order of the surd 2? But I have to convert this surd, quadratic surd, to surd of order 10. How? Means, you see here, Nana, solutions. You see clearly, one by one we'll do. Solution. See here, root 2 can be written as to the power of 1 by 2. Here, I want to multiply 5, divide with 5. So 10. So that 2 to the power of 5 whole to the power of 1 by 10 can be written as 10th root of 32. So we converted this root 2 of order 10. You can convert to any order. Take down this example. Cube root of 2 is given. 2 to the power of 1 by 3. We have to change this to sort of order 9. How? Just you multiply 3 and divide with 3. It become what? 9. So 2 cube whole to the power of 1 by 9. So 9th root of 8 you are getting. I want to change this one to order 15. Yes, you can convert the given surd into any order. What I mean to say that you can convert the given surd into any order. That is important. 2 to the power of 5 by 15. I multiply 5 divided with 5. The new in the power. So now it can be what? 32 to the power of 1 by 15 or 15th root of 32. You can write. Hope so that you understood this all thing, guys. Right? I discuss here order of the surd. Immediately I discuss here. Immediately I discuss how to convert the given one into a given order. Right? We'll go for the next one, Nana. Yeah, we'll move on to the second question. The second question is, express the following surd as a pure surd. Guys, you please remember, these are very, very important. Why? Because you will learn here how to write as a pure. So 3 is there. What is the order of the surd surd? 2. So we have to write the outside number. If you want to take inside, it will, you are supposed to write how many times? 2 times you have to write. Right? 2 as usual, this is. So result is 9 2s are 18 you are getting. I want to give one more example here so that you can get clarity. 1 by 3 root 5 is there. So what to do here? The 1 by 3 you take inside. How many times? 2 times. 1 by 3, 5. Okay. This is. So you will get here 5 by 9. Okay, this is what enter side. Enter surd. Here 2 is there, but cube root. How many times you have to write here? Cube root of already 1. Okay. If you assume that this is 3 by 2. This 2 you have to write how many times? 2, 3 times you have to write. Based on order, you have to write that many number of times. So cube root of, you want to get cancelled, you will get what? 12. I'll take one more example here. Right, 3 cube root of 5 is there. So this is how you take inside. How many times? 3 you have to write 3 times into 5. Now you see this one, order is 4. So 5 you have to write how many times? 5 times you have to write. 4 times, sorry. 4 is there, 4. Right. So that 4th root of 625 into 2, you are supposed to write Nana. Right. So 1250 probably. 1250 you will get here like this. So given surd into, we are going to express as a pure surd. This is one of the best example. Now we'll move on to the next question, Nana. Yeah, you see this one, Nana. Here pure surds are given. We are going to convert into mixed surd. How to write here? You know very well, this is what factor of 16 5s are. Right, sir? 16 5s you can write. That means here you can write 4 how many times? 2 times. right guys? That means 4 root of 5. We converted this pure surd into mixed surd. Yeah, you see this one. This one is also very, very important. 16 threes are 48. So 4 root 3 you can write. Whereas here, cube root of 2 to the power of 7 nano. So you can write here how many times? 2, 2, 2, 3 times, 2, 2, 2, 3 times, and 1 time. So that means for every 3, 1 time you have to write outside. So finally you have what? Write this. So 4 cube root of 2 mixed surd. We converted this entire side into mixed surd. So the two ways I shown to you. If mixed surd is given, how to convert as a entire side, and entire side is given, how to convert into mixed surd. I discuss here these two. Now with the help, these when you learn these three, right? First question, second question, third question. So now it's time. I'll give the question here. Now you have to take care of what you are going to do according to the question. Right, Nana? See the questions. Here, interesting questions you see. You see here, guys. Some are in pure form, some are what mixed form, but we are supposed to simplify. You take care of this, Nana. Here, what he has given here, this is not cube root, Nana. It is what 3 under root 3 root 45. He has given. Right, 3 root 45, this is not 2. So 3 into 45, you see here, best possibility. 9 5s are 45. Yeah, 20, 5 4s are, yes, sir. 7, root 5. Yeah, absolutely, it is nothing, no need to change anything here. If it is required, then only you change, otherwise, no need to change. This can be written as what, Anna? This 9 you can write outside 3. Already 3 is there, therefore we will get here a 9 root 5. Here 2 root 5. Here 7 root 5. Guys, 9 plus 7, 16. 16 minus 2, 14 root 5 is the answer. We express this as a 14 root 5 nano. Now come to the next one. What is this? Here 4 into 11, 5. This you can write as 176 is there. 11 16s, I think. Right, 2. And here 9 into 11, sir. So you see 2 root 11 minus 20 root 11 plus 6 root 11, right? 6 plus 2, 8. If you remove this, minus 14 root 11. Cube root is there. I would like to simplify here, right? Yeah, fine. Yeah, as I said to you that I am going to simplify. I simplified like this. I want to express as a cube root. Okay, to evaluate cube root, what are the possibilities here that I wrote here? 3 here, 3 cube, 5 cube, 2 cube, and then afterwards I started simplifying, writing this cube. 3 outside means 6, 5 outside means 15, 2 outside means 14. If you simplify, you will get this number. Now I want to tell you one more question here, interesting question here, how to multiply. How we are going to simplify, how we are going to multiply this nana. Rational 6, root x, root x, root x whole square. That is what finally you are getting what x here. And this is what 10 root x you will get. When you multiply, this is what 2x and 2 root ax you are getting. I would like to take some more examples, guys. Yeah, some more examples now. How we are going to write a plus b whole square. 2 root 3 whole square, a square plus b square plus 2ab, 2 root 3, 3 root 2. You see this now. 4 3s are 12, 3 4s are 3, 9 2s are 18 plus 4 3s are 12, root 2 into root 3, root 6. Like this we are getting. That is what here 30 plus 12 root 6 we got it. Whereas in the case of a minus b, root a plus x whole square, a square plus b square, right, minus 2ab, right? We expanded here and we got it a plus x, a minus x, 2 root of a square minus x square. So finally, we got it 2a minus 2 root of a square minus x square. Yeah, be careful, Nana. If you think, generally don't multiply. You just think about it. This is what A, B. This is A, B is there. So A minus B into A plus B means, A square minus B square formula apply. Yeah, we can apply all. This is what 2 plus A square plus B square plus 2 root 6, and here it is minus 5. So answer is 2 root 6 is the answer. Whereas here, just you multiply inside. What happened? X plus y and root over x plus y. So I discussed how to multiply surds also. Now I'll go to the next. Okay, guys. Now whatever we learned today, right till now, let us go for this type of question. Usually this type of questions are asked in IITs, but this is not IIT on a basic level. It's a training how to match, right? The answer is this now. See this very clearly, you know very well. I think most of the student can do this bit better. So entire side, what is the entire side? Entire side means A maps to what is the entire side here? This is D. A maps to D. And B maps to similar sets. Where are the similar sets? This. Because same set with different multiples. That is what Q. Similar set. Now come down to the mixed set. What is a mixed set? Sir, this is mixed set. This is mixed set. Right. This all. This is also mixed set. So that you can say P is mixed set. Q is mixed set. R is a mixed set. Different rational multiple, na? Yeah, rational multiples, I said non-zero rational multiple. 1 is also there. So D also I can write. And this is, okay. Suppose here I want to write here entirely different, Nana. Okay. Actually, this is not there. But different. I should write here root 5. Okay. Right. Now, this is E, Nana. So, what is the binomial, sir? Binomial means this is a binomial, 2 terms are there, this is time. So P and E are the binomial. This is the answer for this. Now come down to the next one. You check yourself. A maps to what? Surd. Yes, sir. Q, surd. Okay. This is Q, surd. R and yes. PQRS. Yes, sir. R and yes. These all are surds. Of course, this is monomial. These two are binomial. So B1 is what? Not a surd. Absolutely right. P. E will get it. So next one is what? C. Mixed surd. What are the mixed surds? That means Q and R are mixed surd. Come down to the next one. D. What are the binomial surd? R and S are binomial surd. Like this, we did it now. Okay, shall we go for another question, sir, where you are learning something else? Yeah. Yes, sir. Now you see this one again. What is that? How to compare two surds. Here I want to discuss two cases now. Same order surd, different order surd. You see that these are what binomial surds have taken here. Same order surd. If same order surd is there, just to compare the radicand. So 2 is less than 5. So simply you can say that root 2 is less than root 5. That's it. So you can write here root 8 is less than root 8. Whereas here root 8 is greater than root 13. Just to compare the radicand, you will get it. Okay, now I want to tell you one thing here. Same order I said, cube root of 2, cube root of 7 is there. Which one is means? Just simply cube root of 2 is less than cube root of 7. You won't get any kind of disturbance here, any kind of problem here. Directly you can write by seeing the radicand, provided if the two sides are what? Same order. If different order sets are given, then you land in trouble. A square root and cube root is given. How? How to compare? So you make the order same. You take LCM of what is the order of this one? Order of this one is 2. Order of this one is 3. What is the LCM of this two? 6. So you first raise both to order 6. Then you compare. So how 2 to the power of 1 by 2 is there? 3 to the power of 1 by 3 is there. You see here, both I want to write here in a different way. You see, 2 to the power of, what I can write here, I want to raise the power 6 now. So 3 by 6 here. 3, 2 by 6 here. Now you see this next step, you can write 6th root of 8. And here sixth root of 9. Order is same. Make the order same. Simply, if you want to compare, first you make the order same, then you compare the radicand. Which one is greater? 8 is less than 9. So you can say that root 2 is less than cube root of 3. In the same fashion, here I have taken here another example. What is that, Nana? You see this? 5 to the power of 1 by 2, 15 to the power of 1 by 4. LCM is what? 4. Simply you can raise this one, 2 and 4 here. You don't touch this one because we already make the power is order of the surd is same. This is 25, fourth root of 15. Clearly, 25 is greater than 15. So fourth root of 25 is greater than fourth root of 15. Or you can say that root 5 is greater than fourth root of 15. Right? Make the order equal, then compare the radicand. You can easily get the answer. Right, sir? I discussed two cases here. Yeah. You see the next question. They may ask you that like this. Arrange the following surds in ascending order of magnitude. So what to do here? First, you see the different order surds are given. So we cannot do anything now. What we are supposed to do first, you have to make the order of the surds are what? Same. So now you see LCM. What is the LCM of 2, 3, 4, sir? Is 12. You make the power of this 3 as 12 nano. That is 3 to the power of 6 by 12. Yeah, you can write here. So 12th root of 3 to the power of 6. 3 to the power of 6 value is 729, I think. Like this. And the cube root of 7 is there. Cube root of 4 is there. Sorry. Cube root of 4 is there. 3 to the power of 4 by 12. So you can write here 12th root of 81. You can write this. Sorry, this is not cube root. Let me write here once again clearly. Cube root of 4 is there. Fourth root of 1 by 3. This can be written as 4 to the power of 4 and 1 by 12. So that 12th root of 256, 16 16s are. And the next one is fourth root of 6 is given. So 6 to the power of 1 by 4 is there. You can write 6 cube by 12. This is 12th root of 6 cube is 216. Right. When rad see when the power is same, order is same. I'm going to say that order is same. Then you can compare 729, 256, and 216. Which one? This is the way is there. So small to big, ascending order. What you are supposed to write? Fourth root of 6 is less than cube root of 4 is less than, right? And root 3. In this way we did it. Now come down to the next one, Nana. What is that? Here LCM. Same. First thing what you have to do? LCM you have to take. 2, 3, 6. LCM is 6. So here root 5. Root 5 means 5 to the power of 3 by 6 you can write. So 125 you will get. 6th root of 125. Now cube root of 10 is there. This can be written as 10 to the power of 6 by, sorry, 2 by 6. So this is 6th root of 100 you can write. Nice. First take 2 inside. 6th root of 8 into 3 nana. That is 6th root of here. 6th root of what you will get? 16. 16 you will get. So now you can write here ascending order, small to big. Small to big. What is that? So 2, 6 root of 3 is less than cube root of 10 is less than root 5. This is ascending order. In the same fashion, you can go for descending order also. Now I'll move on to the next question. Okay, now we are going to enter into another phase of surd. What is that? Here we are going to discuss first rationalizing factor. Right. Then afterwards, all the three cases we'll discuss. Then afterwards, we'll go for square root of a surd, how to find, cube root of a surd, how to find. That also we'll do. And once again, we'll come to the comparison of surds. I said only monomial. Comparison of binomial surd also I discussed. Right, sir? Let us start here. You see this? Okay. Now, I'll move on to the next one. Yes, sir. Here, first we'll go for, instead of rationalizing factor, right? Instead of rationalizing factor, we'll go for right. How to find square root, right? Square root, cube root, then rationalizing factor will go now. Now here we see finding square root. See here, finding square root, square root, right? Here several questions. I'll take here 5 types of questions are there. Type 1. In type 1, 5 plus 2 root 6. One example. Two examples I'll take, sir. First question. Okay. And second question is, yeah, in type 1, you please, square root means this 5 plus 2 root 6. The easiest method I'll tell you, sir, without wasting the time. You first, the internal radicand is there, that one you have to express as a product of two integers. What is that? 3 2s are. You just multiply, when you multiply, you should get 6. When you are going to add these two numbers, you should get this one. Such a factor you have to get it. 1 into 6 is also there, but that is not suitable for this. 1 plus 6 is what? 7, not suitable. So what to do here? Suitable one you have to write here, like this. And afterwards, you write here like this 3 plus 2 root 3 root 2. You can write yes. And this can be written as root 3 whole square plus root 2 whole square plus 2 root 3 root 2. In type 1, I'm doing here root 3 plus root 2 whole square. So finally, write always bigger one first, Nana, is safer side, because result of square root is always positive. One example. Yeah, I want to take minus example. 11 minus 2 root 30. Right. How to do? Square root is nothing but 11 minus 2 root 30. See here, 2 into 15 is also there. But when you add, you are not getting this one. So 3 into 10 also is there, but not getting this one. That now 5 6 are 30. Yeah, fine. You are getting here now. 11 minus 2 root of 6 into 5. Bigger one first you have to write, sir. There is no question about that. 5. 2 root 6 root 5. So how much, sir? Yeah, root 6 minus bigger one first you have to write whole square. The result of this one is always positive. That's why answer is this number. I've taken 2 examples for type. Now I'll go for type 2 now. Because 2 is available here, that's why I said type 1. The type 2, what is that? Something extra, like in 12 plus 4 root 7, 4 root 5 is there. Another one I'll take here, 7 plus 4 root 3 I'll take. 2 examples. In this type 2, you see 12 plus 4 root 5 is there. We want 2 only, because a plus b whole square, a minus b whole square, you have what? 2ab. That's why you better take down here, write the product of 2. Right, product of 2 you write down. And as you know that you have learned that method, right? Here you take 2 inside, you will get here 4 into 5, but this is not suitable one. 12 we want, 20 is there, no. 20 is there means 10 into 2 is suitable one, so that it can be written as 10 plus 2 plus 2 root 10 root 2. So finally you have to write here root 10 plus root 2 whole square. Then your answer is root 2 plus root 10 plus root. Yeah, instead of 4, I want to take some other different example, not this, because already I have taken one example where we have what? 4. Now I would like to go with second example in a little bit different. 28 minus 6 root 3. Right. Square root we are finding 6 root 3. How much? Here you see that 2. 6 can be written as 2 into 3. This is root 3 is there. Yeah, you take 28. Take this side 2. 3 inside, Nana. If you take 3 inside, what is going to be happen? 9. 9 into 3, 27. Yeah, 27 into 1 is suitable one. So that you can write as 27 plus 1 minus 2 root 27 root 1. So your answer is root 27 minus 1 whole square, or root 27 minus 1, you can say. This is type 2. We'll move on to straight away, we'll move on to type 3. What is type 3? Type 3, 2 is not available outside. Like this. One example I'll take here. 9 minus root 80 I'll take now. 9 minus root 80. That means square root means 9 minus root 80 I have to write. So 2 is not available here. So what to do? You see that internal one is a factor of 4 or not? Yes, sir. Yeah, 4, 20. Right, sir? Yeah, you can write here 9, 2, right? This is what? 20. Right? Got it. 4 outside means 2 we'll get. So 9 minus 2 root. And now you can factorize type 1. So 4 5s are. So bigger one you have to write first. 4 minus 2 root 5 root 4. So finally root 5 minus root 4 is the answer. I'll take one more example here. You just see this one. 7 minus root 48. Second example, type 3. Yeah, 7 minus root 48. So this can be written as 7 minus. Yeah, you see that 4 is available? Yes, available. So what to do here now? 7 minus 2 root 12. So this can be written as 7 minus 2 root 4 3s are 12. So here 4 plus 3 minus 2 root 4 root 3. Yeah, it can be written as root 4 minus root 3 is the answer. This is type. Now type 4, Nana. Type 4 is entirely different. What is that? Here also I would like to discuss two questions. 2 plus root 5. 2 is neither available inside nor outside. What to do? You multiply, guys. Here root 5. 2 is not available neither outside nor inside. So at that time you multiply, divide with this Nana, and take LCM. 6 plus 2 root 5 divided by root 2. So that 1 by root 2 outside. Yeah, this 6 can be written as 5 plus 1 plus 2 root 5 root 1. Yeah, finally 1 by root 2 root 5 plus 1. We got it. I'll take one more example here with negative. 7 minus root 45. Yeah, square root 7 minus root 45 means 2 by 2 I am multiplying. Yeah, inside 14 2 root 45. 45 means 9 5s are 45. Adding 14. Yeah, root 2 is available. Right, sir? So 1 by root 2 here as it is. Yeah, this can be written as 9 plus 5 minus 2 root 9 root 5. So finally your answer is root 9 minus root 5. Yeah, you can write here 3 minus root 5 also. I discussed 4 types. One more is also there. Fifth one, type 5 Nana. What is that type 5? Type 5 may be like this, sir. One example, 12 root 5 and 2 root 55. One example I've taken. So square root, if you want to find 12 root 5 plus 2 root 55. Be careful. What happened here? You take common one. So 12 plus 2 root 11 is there. So root 5 means fifth root of 1 by 4 will get. And here it is 12 plus 2 root 11 Nana. Fifth root of 1 by 4. This can be written as what, Nana? 11 plus 1 plus 2 root 11 root 1. So fifth root of 1 by 4 root 11 plus 1 is the right answer you will get. And I'll take one more example. No problem for me. Yeah, I'll take one example. Root 50 and root 48 is given. Right. How to do? Under root of root 50 root 48 Nana. So what happened here? This 5 root 2 you can write here. 2 root 4 12 Nana. Like this you can write. Yeah, root 2 you take common. Root of root 2 5 plus 6 2s are. So 2 root 6 is left out. So 2 to the power of 1 by 4. Here 3 plus 2 plus 2 root 3 root 2. So you are getting here 2 to the power of 1 by 4 root 3 plus root 2 is the answer. So square root I discussed thoroughly, perfectly. Right. Another one. Another point is that, yeah, type 6 you see Nana. Here a plus b whole square, a minus b whole square, I use the formula. But whereas a plus b plus c whole square formula, you know very well. a square plus b square plus c square plus 2ab plus 2bc plus 2ca. We can use first finding square root like this also. What is that? You see here under root. This is 10. Luckily, same procedure you have to adopt. 2 must be there outside. The internal one you have to make as a perfect, related factors. Here what? 2 3s are. Right, sir? 2 here. 2 5s are. And this is 2. 3 5s are. Yeah. 3 2 5. Yes, sir. You see, this can be written as 5 plus 3 plus 2. 10. Match with this time. Now I want to write like this. Root 5 root 3 plus 2 root 3 root 2 plus 2 root 2 root 5. Yeah. A square plus b square plus c square plus 2ab plus 2bc plus 2ca. So shall I write here like this? Root 5 plus root 3 plus root 2 whole square. Of course, here minus is there, means according to that changes, you can write. Yeah, I would like to do one method, one problem. I did it. Rest you please try, Nana. Okay, we'll move on to the next one. Yeah, how to find cube root. Now you see this. This is very, very important. Okay, we are coming to the end of the journey. So 9, this is 1. Okay, the result may be at root x plus root 5. You write like this, sir. If it is plus, you write plus over here. But you assume like this now. This is what you are let. Another one again. What cube root of? If it is plus is given, you take minus also. 11 root 2. You take minus 1. If it is minus, here minus you will get. Say this is 1 and this is 2. Now what to do here? Multiply 1 and 2 nana. So cube root of 9 root 3 plus 11 root 2 and cube root of 9 root 3 minus 11 root 2. So root x plus root 5 and root x minus root 5. What you will get here? Cube root of 9 root 3 whole square minus 11 root 2 whole square. You will get, because a minus b into a plus b is there. So this is what x minus y, you will get it, Nana. So now after evaluating this, what you are going to get? See, 81 3s are cube root of 81 into 3. Here 121 into 2 nana is equal to x minus y. So I think you are getting 1 over here. This is what? X minus y. This is x minus y. We got it. Okay. After getting x minus y, you take the first one from 1. What is the first one? Cube root of 9 root 3 plus 11 root 2. Right, sir? Root x plus root 5. So CBS. Cubing on both sides. What happened? 9 root 3 plus 11 root 2. Okay. And this a cube, x cube, b cube plus 3a square b plus 3ab square, like this. So you are getting here x root x, y root 5, here 3xy root 3y root x you are getting. So this is what, like this, Nana, x plus 3y root x and y plus 3x root 5. This you are getting what? 3 root 3, 11 root 2 is here. When you start comparing here, 9 is equal to root x. Sorry, rational, irrational part you can compare. Directly you can take here. X is equal to 3, y is equal to u2. You can take like that. Or else you can take x minus 3y is equal to 9 and y plus 3x is equal to 11. Even though if you solve, you will get the same answer. Same answers. Okay, like this you solve, and finally you can write the result. What is the result of this? Root x plus root 5. So that root x means root 3 plus root 2 you are getting here like this. Now you just check it out here. Whatever you are taking here, whether you have to take here x as 2, y is 3 means 2 minus 3, it is not satisfying this one. This is most important. Why we did this? After analyzing, for example, you might have said like this, sir, x is equal to 2, y is equal to 3. X is equal to 2, y is equal to 3 never satisfied this equation. -1 you will get. Now minus, here it is 1 is there. That's why this is for cross-checking point of view, you have to do this. And for result point of view, you have to go for cubing. Right, guys? Yeah, we did it. One cube root problem also, sir. Yeah. You see that what is the rationalizing factor? When you multiply two surds, the result is rational number. Then these two surd, one is a rationalizing factor of other, we can say. Right, sir? So here, for example, you see mathematically how nth root of A, nth root of B I have taken are two surds. When you multiply, the result is what rational you got it. Then you can say that this is a rationalizing factor of this. This is a rationalizing factor of this one. Right. For example, I'll write here. You see this RF of root 2. What is the RF of root 2 means? People are going to say like this, is root 2. I will say not only root 2, 3 root 2 is 3 root 2, correct? Is 1 by root 2, correct? Is minus 5 root 2, correct? Like this. You can give n number of examples. So what I can say here now, RF of a surd is not unique. Not unique. But generally we would like to take here some, I want to say that what some least one we are going to take, Nana. Least one we are going to take. Right. I would like to discuss all the cases here. See, yeah. In the case of RF, I would like to discuss 3 cases now. Case 1 I will discuss. You see this, guys, you remember this formula, x square minus y square. What is that formula? X minus y into x plus y. Suppose if I write here x cube minus y cube, you will get here x minus y into x square plus xy. Gradually x power is decreases by 1. At the same time, y is increases. X to the power of 4, y to the power of 4. Yeah, x minus y. And here x cube, x square y, xy plus xy square, you will y cube, xy square, here y, xy square here. Then afterwards, finally, we may get here y cube. This is right. This is will get. So in the same way, x to the power of n minus y to the power of n, if I write x minus y, right, x to the power of n minus 1, x to the power of n minus 2, y, so on, y to the power of n minus 1, you can write. Remember what I want to say, product means these are the surd. This is surd 1 and this is surd 2. When you multiply, you will get something. This is rational number. You remember this. So I'll give you examples here. You see this. Suppose root 2 plus root 2 minus root 5. 1. Yeah. Quite opposite also I'll give. Don't worry. Root 3 minus root 5. RF of this is what, Nana? This one you have to write. That is root 2 plus root 3. So 5 minus root 3 is RF is what? 5 plus root 3. Simply. This is one example. One example. This is second example. Third example. See, suppose if I write cube root of 3 minus cube root of 2. That means I'm not giving this. I have given this one. What is the RF? You are supposed to write this. What is that? Cube root of 3 is your x whole square. Cube root of 3, cube root of 2, and cube root of 2 whole square you have to write. This is your RF. See, this is given me. This you have to write now that I wrote here. Right, sir? This is RF of this one. Okay, I'll give one more example here. Now, see, cube root of 1 RF of cube root of 2 minus 1 is there. Is what? See this one. Yeah, I can write cube root of 2 whole square plus cube root of 2. 1 cube root of 1 means 1 only. And next cube root of 1 whole square means, yeah, same thing. You are getting what? Here cube root of 4 square inside you can multiply, not for 3. Cube root of 2 plus 1 you will get like this. One more I would like to give. I'm not giving 4, 5, etc. unnecessarily wasting of time. You just see this one, but it's you should know this all, right? Yeah, you see here, cube root of 5 minus cube root of 7 is there. You can understood now this one. What is the RF? RF of this one is what, Nana? Cube root of 5 whole square plus cube root of 5 cube root of 7 plus cube root of 7 whole square you can write. If you simplify, cube root of 25 cube root of 35 because 7 3 is 7 5 is 35 and cube root of 49. Yeah, this is your RF. Right now, so case 1 is clear. Now I'm not satisfied with this one. Ulta. Suppose if he has given here like this. Some other example. RF of suppose cube root of 9. Okay, cube root of 3, cube root of 2 and given, and cube root of 4 is given. How is what means? You see that one? This is what you can write. Cube root of 3 plus cube root of 3 minus, because all are pluses, so that you can write here directly cube root of 3 cube root of 2 you can write. I'll give one more example. No problem. No problem. A cube root of RF of Nana, cube root of 5 25, right? I think if I give like this, you people can catch easily. Cube root of 5 whole square plus cube root of 5 plus 1. What is that RF? Yeah, 1 is there. So cube root of 5 is 1 minus 1. Right? Okay, guys. Like this you can find. Right, Anna? Yeah. Another one. RF of. Remember, if he has given cube root of 3 minus cube root of 1 by 2, you would have read is this now cube root of 3 whole square plus cube root of 3 cube root of 1 by 2 plus cube root of 1 by 2 whole square, like this. Suppose if he has given like this, cube root of 5 whole square plus cube root of 5 cube root of 2 and cube root of 2 whole square RF of this, then your answer is what? Cube root of 5 minus cube root of 2. Please be careful here. Cube root of here 16 plus cube root of 12 plus cube root of 9. What is RF? This means cube root of 4 minus cube root of 3. You can write. I have given several examples. This is 1, 2, 3, 4, 5 examples I have given for type 1. Now I'll go for type 2, Nana. Okay, case. Yeah, 2 more cases I said it now. N is even, N is odd. Yeah, you see these are the formulas. So what here for this one I would like to give RF. What, Nana? You see that I would like to give example here. RF of. RF of. If he has given this one, that's what? Root 2 plus root 3 is given. Your answer is what? Root 3 minus root 2 plus root 2 minus root 3. Suppose if he has given here RF of, you see, 4th root of 2 minus plus 4th root of 3 is given. So what you have to write is 4th root of 2 whole cube minus 4th root of 2 whole square 4th root of 3, right? Plus, sir, plus here 4th root of 2, then 4th root of 3 whole square minus 4th root of 3 whole square. You can write like this. I have given 2 examples here. For this one, very simple. What is that? Cube root of 2 plus cube root of 3 is given. What is the RF? RF of this is what? You have to write this one. What is that, Nana? Cube root of 2 whole square minus cube root of 2 cube root of 3 plus cube root of 3 whole square you can write. I'll take one more example. Cube root of 5 plus 1 is there. Is what? This is one example. This is second example. is cube root of 5 whole square minus cube root of 5 cube root of 1 and here cube root of 1 whole square. Most important one is in this two, what is the different? Last term is negative. In this one, last term is positive. Even though alternately minus we are getting in the second factor, but here last term is negative when n is even. And when n is odd, last term is positive. Please remember this. So guys, here in this class, what I did, I tried my level best to explain all the theoretical points, right? All the theoretical points I explained here. I explained all the theoretical points. But then a question is, in the next class, I'll give one assignment. We'll discuss. We'll have a good discussion on assignment because I introduced all the concept of Surds. Now it is your turn. You're supposed to take care of then all the concepts. Next one, in the next class, I'll give assignment. That assignment we'll discuss. We have a good discussion. Okay, guys. Bye.